Good morning and welcome to Wednesday's maths lesson where we will be looking at volume. So our what is to calculate the volume of a cuboid. So here is our Fluency first for today, which is a bit of a rewind. So we're going to have a think about what is volume. What do we mean by it? So we've got Rena and Zach here having a discussion. So obviously if we were in school normally, we would have these little Dean's cubes or the little multi-link cubes out in front of you. Unfortunately, we're not going to be able to use those. And I don't think you've got any at home unless for some reason you do, in which case brilliant. So this is going to be a lot more visualising than we would normally do, but that's okay. Okay, we can still do this topic without the cubes. And when we are back in school, we can then do some lessons with the cubes. So we have got Rena and she says our shapes look different. And Zach says, I think our cubes have got the same volume. So he thinks their volume is the same. Rena thinks, but they're different though. So how can they have the same volume? So I just want you to think about, is Zach correct? And what do you think is meant by volume? Pause the video, have a go. Okay, so when I say volume, what I mean is the amount of space inside a 3D shape. And I'll show you that STEM sentence in a moment for you to write down. So the volume is the amount of space inside a 3D shape. So area is the amount of space inside a 2D shape, two-dimensional. Volume is the amount of space inside a 3D shape. It is three-dimensional. So it's got length, width, and height. So we're now talking about things like a box, okay? That is a 3D shape. So what we can think about when we're talking about volume is we talk about things in centimetres cubed. So in area, we were looking at centimetres squared, because it was 2 dimensions. Now we are looking at centimetres cubed because it's 3 dimensions. So each one of those little cubes that they have used to create their shapes, each one of those is 1 centimetre cubed. So all I want you to do is I want to count. How many cubes has Rena got, and therefore what's her volume? How many cubes has Zach got? And be careful, some are hiding. So what's the volume of his shape? Well, Rena has got 3 in a line, and then 2 more, 5, and then 1 on the top, 6. So the volume of her shape is 6 centimetres cubed. Zach's, he's got a base layer that you can't see, but there must be a base layer there for that top cube to be standing there. So he must have a base layer of 4 cubes, 2 on the top, 6. So his volume is 6 centimetres cubed. So although their shapes are very different, they do have the same volume. Right then, next bit of the Fluency first. I want you to have a go at working out the volumes of all of these shapes. How many unit cubes or centimetres cubed would the volume be? So all you've got to do, just count the cubes. Just make sure you're not missing any because you can't see them doesn't mean they're not there. So A would be 1, 2, 3, 4, 5, 6, 7, 8. 8 unit cubes or 8 centimetres cubed. B, well, you've got 5 along the bottom, 3 on the top, 8 centimetres cubed. C, so C, the sum you can't see. So the base layer would be 1, 2, 3, 4 times 1, 2, 3, 4. So 4 times 4 is 16. So there's 16 on the base, 4 on the top, 20 unit cubes or 20 centimetres cubed. D then, might have to do a bit of working out for D. So I look at D and I can see that along the base it's 2 times 1, 2, 3, 4. So that base layer is 8 cubes. The next layer up is 6 cubes. The next layer up is 4 cubes and the top layer is 2 cubes. So I'm going to add these up. So 8 add 2 is 10, 6 add 4 is 10. So altogether 20 cubes or 20 centimetres cubed. Right then, discover time. So if you haven't already, write discover into your blue practice book and let's have a look at today's problem. So we've got Jamila and we've got Max. Jamila is saying, my solid has a greater volume than yours. It takes up more space. Max is saying, we are both using cubes that each have a volume of 1 centimetre cube. Okay, Max is correct. And you can see there, that is how you write centimetres cubed, just like we would when we say cubed normally. So 2 cubed is 2 times 2 times 2. This is exactly the same idea, okay? So we need to have a think about, is Jamila correct? Does her solid have a greater volume than Max's solid? Okay, I've zoomed in a little bit so you can see it a little bit clearer. Here is Jamila's shape, or solid as she is calling it. So what is the volume of this shape? And then here is Max's shape, or Max's solid. What is the volume of this one? Okay, answer time. So if you've not done it already, keep the video paused. If you have, brilliant, let's get going. So for Jamila then, you can see that she's got a bottom layer, and that bottom layer is 6 cubes. 6 cubic centimetres, 6 centimetres cubed. She's then also got that little top layer as well, which tells me that the volume of Jamila's is 8 centimetres cubed, because she's got 8 cubes, 8 centimetres cubed. And like we said earlier, we write that little 3 just like we would when we're talking about cubing a number normally. So this says 8 centimetres cubed. Well done if you got that right. Right then, Max's term. So Max has made a cube. So this means that all the sides are the same length. So it means it's got 6 square faces and each one is the same. So there's a couple of ways you can think about this. You can either see that on the bottom, on the base, it is 2 times 2, which is 4. So it's 4 cubes on the bottom. And then there are 2 layers of 4. So you can do 2 times 4, which is 8. 8 cubes, which is 8 centimetres cubed. The other way you can think about this is because this is a cube, you can see that it's got a width of 2, a length of 2, and a height of 2. So you can say 2 times 2 times 2, which of course is the same way as saying 4 times 2, isn't it? 2 times 2 times 2 is also the same as saying 2 cubed, which would be 8. 8 centimetres cubed. So the same answer, 2 different ways of getting there, okay? But it doesn't matter which one. So although their shapes were very different, they both had a volume of 8 centimetres cubed. So actually, Jamila wasn't correct. Although the shapes were different, they did have the same volume. Well done. Think together time. So write think together into your blue book, and we're going to have a go at working out the volumes of these cuboids. So a cuboid is a 3D shape. It is similar to a cube, but a cube has got 6 faces the same, whereas a cuboid has got 2 faces the same and then 4 faces the same. So the 2 end faces will be the same, and then the 4 faces around the middle, they will then be the same. Okay, so a cuboid is a little bit different to a cube. A cube, they are all the same. A cuboid, they are not, and it's made up of rectangles and square faces. Okay then, let's have a go at working out the volume of these cuboids. So all you need to do is count the squares. The cubes, sorry, not the squares, the cubes. So you're going to count the cubes. Pause video, have a go. Right, for A then, you can see that that bottom layer, the yellow layer, is made up of how many cubes? 10. And that's because you've done 2 times 5, 2 lots of 5, or 5 lots of 2. Okay, the width is 2, the length is 5, so one layer is 10 cubes. But then you've also got another layer of 10 cubes. So we can do 10 times 2, which is 20. 20 cubes, which is the same as saying 20 centimetres cubed, because each part of the cube is 1 centimetre. So each cube is 1 centimetre cubed, and there's 20, so it's 20 centimetres cubed. Hopefully you can see on the right hand side how you can also write this out rather than always counting the cubes. So this is the more efficient way of working out the volume. So you work out how many cubes long it is, how many cubes wide it is, how many cubes high it is, and times them together. So you can see here I've done 2 times 5, which helps me find kind of the base layer, and then I've times it by 2, which is the height, to find 20. For B then, let's look at the bottom layer first of all. So I can see that it's got a length of 3, it's got a width of 4, and then I can see it's got a height of 2 because there's 2 layers of cubes. So for the volume then, I'm going to do 3 times 4, 3 lots of 4, which would be 12. So I know that one base layer is 12 cubes. There's 2 layers, so 12 times 2 is 24 cubes, which is 24 centimetres cubed. Well done if you got these right. Right then, nearly done with flying through this lesson. So this is your independent activity. So you've got 1A, B and C. How many centimetre cubes are there? So then what's the volume? Off we go. Well, for this one, they weren't cuboids, they were irregular 3D shapes, so we couldn't there wasn't any easy, quick way of doing this. So we just had to count the cubes. So count the cubes. For A, there was 6 cubes, so there was 6 centimetres cubed. For B, there was 8 1 centimetre cubed cubes, so the volume was 8 centimetres cubed. And for C, the volume was also 8 centimetres cubed, because remember, there was 2 hiding underneath those top 2, so there was 8 cubes altogether. Okay then, have a go at number 2. So match the 3D shapes that have the same volume. Pause the video, have a go. Answer time for this one then. So we have got, I've worked out the volumes for the left-hand side and I wrote those down. So I wrote down as much information as I could. So for A then, I could see that the base would be 3 times 3, which is 9. The height would be 3, so it's 3 times 3 times 3, or 3 cubed, which is 27 centimetres cubed. Then I worked out the volume of B, which was obvious, 4 centimetres cubed. C was 8 centimetres cubed, and D was 20 centimetres cubed, because it was 5 times 4 times 1. Then I had a look at the other side and just worked out which ones match with which. So number 1 was 4 cubes, so it matched with B. Number 2 was 20 cubes, so it matched with D. 3 was 8 cubes, so it matched with C. And 4 had to do a little bit more counting because there was quite a few hidden, but there was 27 cubes or 27 centimetres cubed, so it matched with A. Well done if you got those right. Last 2 questions for today then. Pause the video and have a go at these. Answer time then. So for this top one is an explain it question. Lee says the volume is 6 centimetres cubed. What mistake has he made? And hopefully you didn't write, he hasn't made one, which some people sometimes do. Because if it's telling you he's made a mistake, he's made a mistake. So looking at the diagram then, I can see 6 cubes, which would make me think that the volume is 6 centimetres cubed. However, those 2 cubes on the top can't just be floating in midair. There must be a cube underneath it holding it up. So there must be a line of 3 and then 2 more on the side and 2 more on the top. So the volume is then 7 centimetres cubed. For the last question, we're working out the volume, nice and easy. So for A, it is 5 cubes wide, 2 cubes long, and 3 cubes high. So I'm doing 5 times 2 times 3, which would then be 10 times 3, which would be 30 centimetres cubed. And for B, I'm doing 3 times 4 times 2, which would be 24 centimetres cubed. Really well done for this lesson today. Take a picture of your work, send it in to me, and I can give you some dojos. See you later. Bye.